Okay, so in today's video, we are going to be continuing with quadratic equations. And what we're going to do today is we're just going to graph a quadratic equation. And similar to how we did with linear equations in graphing y equals x, with quadratic equations, we're just going to graph y equals x squared. Okay? And again, we're going to graph this kind of base graph, and then from there, we're going to create our customizations to that graph. So we'll be able to shift it upwards or downwards, left or right, and we'll be able to stretch it out or compress it. Okay, and similarly to how we did with linear equations, all we're going to do is we're just going to think of a table here, and we're going to fill in that table. So we'll have a y portion and an x portion for that table, and we'll basically just select some numbers and put them into our equation and see what we get. Okay, and what we're going to do here is we're just going to select between the numbers of 3 and -3. So we're going to go 3, 2, 1, 0, and -1, -2, and -3. Okay, so for each of these x values, we ask ourselves what is the y value. And that's pretty easy to do here. We're just going to substitute in all of these x values into our equation y equals x and see what we get. So in this case, if we substitute 3 in for x, we're going to get y equals 3 squared. 3 squared is just 9. So when x is equal to 3, y is equal to 9. When x is equal to 2, same thing, we're going to get y equals 2 squared now. 2 squared we know is 4. So when x is 2, y is 4. When x is 1, y is also 1. When x is 0, y is also 0. Okay, and now we're going to do the same thing with the negative numbers. So if we substitute -1 in here, we get -1 times -1, which is +1. If we substitute in -2, we get -2 squared. -2 times -2 is +4. And with -3, we get +9. So you can see that there is some inherent symmetry with quadratic equations, which makes sense because in the previous video we talked about certain concepts of quadratic equations, one of them being the axis of symmetry and the vertex. And so we're going to see that again in this video. So if we were to take these points here, so in this case 3 comma 9 and 2 comma 4, and so on and so forth, 1 1, our origin 0 0, and -1 1, and -2 4, and -3 9. If we were to take these points and graph them on a piece of graph paper, then this is what we would get. This is what our equation would look like. Okay, and so with this, we can see that again there is some sort of symmetry here, and we can talk about that. So let's go ahead and actually uh, go through some of these points. So obviously we would love to see 3 9, but it doesn't really fit on our graph here. So we'll go to 2 comma 4. So 2 4 is going to be right here. Okay, sorry, there we go. 2 4 is going to be right here. We can label that as 2 comma 4. Okay, so we have that point. We have 1 comma 1, which is going to be right here. We'll label that one as well. Then we have 0 0, or our origin. That one's pretty easy. And then we have -1 1, which is going to be right here. And then -2 comma 4, that's going to be right here. Okay, so those are some of our points. And again, if you connect them, you'll get this quadratic equation or this graph. A few other things we can talk about from last video. We can talk about the vertex, the axis of symmetry, the intercepts, and the way that this graph opens up. Okay, so as I said, the graph opens up. Hopefully you remember from last video, opens up or opens upwards. The way you can remember this is if it makes a U or it makes the letter U, it opens up, U up. So this opens upwards. Another thing we can talk about is the vertex and the axis of symmetry. These two are sort of related. Um, we'll first talk about the vertex. So remember, the vertex is either the maximum or the minimum point of a quadratic equation. Now in this case, it's not a maximum because one, it opens upwards, and so we know we're going to have a minimum, but also we know that if we try and get a maximum, this graph just it just goes on forever. We should put little arrows on here because it goes on forever, and so technically there is no maximum. The maximum is infinity, and that wouldn't really make sense to call that a maximum. And so we know that there's a minimum. Where is that minimum located? Well, it seems like it's located right here. Okay, so that is our minimum, and that's also where our vertex is located. So we can label this as the vertex. Okay, and we know the vertex is, in this case, 0, 0. Okay, and going along with the vertex, we know that the axis of symmetry runs through the vertex vertically. So if I were to draw this sort of dotted line here right on the y-axis, this is what we would call the axis of symmetry. And the reason that it's called the axis of symmetry is because if you were to just take one look to the left or to the right of this line and cover up the other side, so let's say we cover up this left hand side and just look at this right hand side, if you think of putting a mirror where this axis of symmetry is and then looking at the mirror from this right hand side, you would basically see this red line, right? And it would just be flipped on the other side. And then if you took away that mirror, you would see the exact same thing. Okay, so we would have symmetry about the axis of symmetry. And again, that's why it's called the axis of symmetry. So we can label that as the axis of symmetry. And if we want to, we could also label where that axis of symmetry is located. It's located at this line, and this line has equation x equals 0. Okay? Another thing we can talk about is the intercepts of this quadratic equation. So again, we have two different intercepts. We can talk about the x-intercept, or we can talk about the y-intercept. Let's talk about the x-intercept first. So that is where this graph is going to cross the x-axis. Okay, and in this case, there's only one spot where that happens, and it just so happens to be where the vertex also is. Okay, so this is also our x-intercept. Okay, so it's our x-intercept, and again, we can label our x-intercept. It happens at x equals 0. And we can also talk about our y-intercept, and that's where our graph crosses the y-axis. And that also happens to be here at the vertex. So this is also our y-intercept because it's where our graph crosses the y-axis. And again, we can label that, and that is located at y equals 0. Okay? So we've talked about all of the features of quadratic equations that we know about. We've talked about the vertex, the axis of symmetry, the x and y intercepts, as well as the opening of the graph, whether it opens up or down. And I guess the last thing we could do is label our graph, and this is y equals x squared. Okay, so this is our base graph, and from here what we can do is we can add things in front of this x squared, we can add things after the x squared, and with that we will change the way that this graph looks. How will we change it? Well, in some cases we will move the vertex up, or move the vertex down, or move the vertex left or right. And in other cases we'll stretch this graph up so it'll be a little bit more narrow instead of being as wide. Or we can widen it and make it wider than it is. We can also, of course, invert it and make it, instead of opening upwards, make it open downwards. And all of these adjustments that we make to the graph, we can see those within our equations and know how those adjustments are affecting our graph. And so the end goal is to basically understand just look at an equation and go, okay, I know how that opens. I know where the vertex is going to be. I know if it's going to have one or two x-intercepts, and I'm going to be able to figure out where the y-intercept is. Okay, so that's kind of the end goal of making adjustments to these quadratic equations and being able to judge what's going to happen to them before we even have to actually graph them on a piece of graph paper. So that's coming up in the next couple of videos.